Welcome to homework.
We are given two context-free grammars which generate two languages, L of G1 and L of G2, and we're given sets, and we are asked to show that there is a context-free grammar generating each of these sets. So in part A, we're given the set which is the union of L of G1 and L of G2. Well, to make this a little bit simpler, suppose that the non-terminal symbols of G1 and G2 are disjoint. And if this is not the case, we can obviously just give the symbols, say those in G2, new names so that the symbols will be disjoint. And this won't change the language that the grammar generates. And we have start symbols S1 and S2. And now we'll define our new grammar, G, by taking all the rules of production from G1 and G2 along with the symbols, so all the rules and symbols from G1 and G2. Add a new symbol S which is the start symbol for G, and in part A, so you're trying to find grammar that generates LG1 union LG2. Well, we want strings that either grammar G1 or grammar G2 generate. So we want to add the rules S produces S1 and the rule S produces S2. And this way we can produce or derive sentences from either grammar. And this is really the contribution for this part. Now in part B, we're asked to find a context-free grammar generating the set L of G1, LG2. So this is the concatenation. So all strings in this set have the form that they start out as a string from L of G1, which is then followed by a string from L of G2. So we'll want to add the rule S produces S1, S2. So this way, our strings are always going to start out with some sentence from the language generated by G1 and then be followed by a sentence from the language generated by G2. And so this gives us a context-free grammar which accomplishes this. And in part C, we're given the set L of G1 star, so the clean closure of L of G1. Well, notice this is going to include the empty string, so just in case L of G1 didn't include the empty string, we'll want to include the rule S produces lambda. We'll want to also recognize that any string from this set is going to have the form of a string which is made up of sentences from L of G1 concatenated together. And so this is going to be, each string is going to be a sentence from L of G1 followed by another sentence of L of G1. And we can represent this with the production S produces S1 S, and in this way we can create strings of this form. And this will give us all strings that consist of the concatenation of any number of strings that the grammar G1 generates.